Hi everybody, this starts the Unit 4 review. Remember in class I mentioned that this video will come out to be longer than most because I plan on going through each and every question, but the intention is not that you listen to every question. The intention is you jump ahead a couple seconds at a time, check your answer. If you match mine, then you're good to move on to the next question, and so on. Any questions that you still have by the end of this video, please don't hesitate to reach out on Remind. Remember, tests are half of your grade. They're important. They are big game day tomorrow, okay? So make sure you send any remaining questions on Remind. Number one, we're going to always be drawing lines down inequality signs. This says -5 times x, so I will divide both sides by -5. When we divide by a negative, the inequality sign changes direction. So x is greater than -6. So we'll put -8, -7, -6. You don't have to get numbers on the whole number line, just a couple on each side would be nice. Open circle on -6 and graph to the right. Number two, line down the inequality sign. Our goal is to isolate where we see x. So for example, on this side I see that I have a +1. I can subtract 1 from both sides. Now we get 6x greater than or equal to 12. That says 6 times x, so I'll divide both sides by 6 and get x is greater than or equal to 2. So again, if you put 2 somewhere kind of in the middle, count backwards if you want to. 1, 0, forwards a couple. That'll be a closed circle on 2 because it's the or equal to sign, and then to the right. Number 3, process does not change, line down the inequality sign. Now here we see that starting with number 3 and on, the questions get a little more involved. So we want to really make sure that we're being strategic in our approach. For number 3, that would mean really taking a close look at the left side and noticing here that I have like terms that I can combine. I cannot stress it enough that we only combine like terms on one side of the equal sign. So for example, you will not see me putting 6 and 21 in a box because those are on opposite sides of this line. You cannot cross this line when you combine like terms. So I can do 9x minus 4x because they're on the same side of the inequality sign, which is, again, why it's really important you draw lines down the inequality sign. It helps you to see each side. So this has become 5x plus 6 less than 21. And now we're back to a two-step inequality. We'll subtract 6 from both sides. If there's something that we can add or subtract, we always do that first. Line all the way across. 5x is less than 21 minus 6, which we should get 15. Divide by 5, divide by 5. X is less than 3. So 1, 2, 3, 4, 5. This will be an open circle on 3. Less than is to the left. Number 4, let's put an inequality sign down, or excuse me, a line down the inequality sign. Again, being observers, I know that I'm going to leave 4x minus 3 alone for a second because there's something I can do with this 2. We can distribute the 2. So that will become 2x plus 6. Now, when we have inequality signs on each side of this line, we need to have that goal in mind. The goal will be all of our variable terms on the left and numbers on the right. So if I look at the left side first, if I just want variables on the left side, this minus 3 can't stay. So we'll add 3 to both sides. So you get 4x greater than or equal to 2x plus 9. If I turn my attention over to the right side here, I just want numbers. So this term right here, 2x, that has to move. It has a variable. So we'll subtract 2x from both sides. That gets us 2x greater than or equal to 9. The last step will be to divide both sides by 2. And we get x is greater than or equal to 4.5. Decimals are okay answers. It does not mean you did something wrong. To graph that, I'm going to go 2, 3, 4, 5, 6. 4.5 will be halfway between 4 and 5, and it's going to be a solid dot. So again, 4.5 is halfway between 4 and 5. Greater than means to the right. Number 5, we have two inequality signs, so I'm going to put two lines, one down this one and one down this one. So now my attention is all on the center because that's where x is. So what we do to the middle, we have to do to each side. For example, I see plus 4. If I want to subtract 4 here, I have to subtract 4 here and subtract 4 right there. So I get 2x in the middle. The inequality signs stay just the way they are. 10 minus 4 is 6. 12 minus 4 is 8. To isolate x, this is 2 times x. I would like to divide. If I divide here, I have to divide on the left and on the right. We get x is greater than 3 and less than 4. Or x is between 3 and 4. Let's get some numbers on the number line here. Both of those are open circles, and I shade in between because x is between 3 and 4. All and inequalities will look just like this. Number 6 is also an and, but notice that it's written with the word and. So let's see how that'll work out. We have two separate inequalities to solve. Here's one, and then here's the other. We'll do one at a time. Let's just focus on this one. Our attention is on the side where we see the variable. M is on the left, so we'll look at the left side first. I see that I have a minus 9 here. I can add 9 to both sides. So I get 7m is less than 54 plus 9. We get 63. We'll divide by 7, divide by 7. M is less than 63 divided by 7 is 9. So that's one piece. I guess I don't have to write it again. Now let's go work on the second piece. My attention again is on the side where the variable is. Here's m on the left, so I'll pay attention to this left side. I will subtract 1 from each side. I get negative 6m is less than negative 30. Divide by negative 6, divide by negative 6. When we divide by a negative, the inequality sign has to change direction. So this becomes m is greater than 5. So my answer is m is less than 9 and m is greater than 5. Let's see what that graph will look like. I need to get 5 and 9 to fit. So 5, 6, 7, 8, 9. Open circles on both. Open circle on 5, open circle on 9. Really think about what an and means, okay? So m is less than 9 means it's going to go this way, and m has to be greater than 5. So it's all values between 5 and 9. Remember, all and inequalities look like this, where we're strictly between two values. There's no arrows going on forever and ever for these ones. Number 7, we're dealing with an or. So right away mentally, I want you to realize that we're going to have one of these situations most likely, okay? Once again, we're going to solve these one at a time. So just paying attention to the one on the left, line down the inequality sign, I pay attention to where I see the variable. Here's n. On this left side, we can add 1 to both sides first. So we get 10n is greater than 0. Right here, sometimes people think that they may have done something wrong. 0 is a perfectly acceptable number to be working with. We'll divide both sides by 10. And we get n is greater than 0 divided by 10 is 0. We're halfway there. We need to come over here and work on this one. So again, we'll pay attention to the side where n is. I have negative 10n plus 1. We'll subtract 1 from both sides. That becomes negative 10n is greater than or equal to 20. Divide by negative 10. Divide by negative 10. As soon as we divide by a negative, that inequality sign changes direction. So this becomes n is less than or equal to negative 2. So our complete answer is n is greater than 0 or n is less than or equal to negative 2. N is greater than 0. That'll be an open circle on 0. Greater is to the right. Or n is less than or equal to. So solid dot and negative 2. Less than is to the left. Number 8 starts our graphing linear inequalities. Our first one here, y is greater than negative 4/5 x plus 1. Well, right away from the inequality sign, I know that this will be a dashed line because I don't see any or equal to. Let's graph it. So mx plus b, m is negative 4/5 and b is 1. We're going to use this piece of information first. So I plot my y-intercept at 1, and then I use my slope as a set of directions. This means down 4, right 5. So from the y-intercept at 1, I'm going to count down 1, 2, 3, 4, right 1, 2, 3, 4, 5. And I can do it again, down 1, 2, 3, 4, right 1, 2, 3, 4, 5. Or from the y-intercept, I could count up 1, 2, 3, 4, up, and then to the left 1, 2, 3, 4, 5. Straight edges are a must. Your ID makes a great straight edge. It's going to be a dashed line. Arrows on each end. To know how we're going to shade, when it's solved for y, we can just look at the inequality sign. It says y is greater than. So greater means shade up. Remember, we talked about how on the x-axis, we have left and right. But we're looking at, just to make it stand out, we are focusing on the y-axis. There is no left or right on the y-axis. Our options are up or down. So greater than, we are going to shade up. In other words, above. You can use up and above interchangeably. If you really wanted to, you could also actually check 0, 0. That will still work out. So just in case there are those who are like, no, I still want to check 0, 0 just in case. That would be 0 is greater than negative 4/5 times 0 plus 1. Comes out to be 0 greater than 0 plus 1. 0 greater than 1. True or false? 0 is not bigger than 1. That's false. So here's 0, 0. If 0, 0 is false, any ordered pair on this side is also false. I go shade the other side. When I ask you for 3 solutions, it could literally be any ordered pair in this shaded region. So maybe I pick this one. That would be 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. So maybe 5, 7 is 1 for me. Another one could be over here. That's 1, 2, 3, 4, 5, 6, 7, 8, 1. And so on, okay? So for these, I will leave those in your capable hands to pick out ordered pairs in the shaded region. I just wanted to make sure you were clear with what I meant by that. Number 9, solve and graph. So now we've stepped it up a little bit because now we're going to be graphing 2 inequalities on the same plane. Remember, we're first just going to get the lines on the graph before we shade, just so we keep it clear with our graphing skills, okay? We're going to circle this one. We'll call this line 1. So for line 1, my slope is -1. My y-intercept is 2. So I'll go to 2 first. -1 means down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. From the inequality sign, I know that this will be a solid line. Let's put arrows on each end. This is really nice because it's already solved for y. Y is greater than. So my question to you, if it says y is greater than, are you going to shade above or below? Greater than means shade above. So make note of that, and we can label this line 1, but we're not going to shade yet, not until we have our other line graphed. So this is going to be line 2. For line 2, the slope is 1/3, and the y-intercept is -2. So I'm going to plot that y-intercept first at -2, and then I'll use my slope to count. Up 1, right, Up 1, right 1, 2, 3. Up 1, right 1, 2, 3. Get one more point. Up 1, 1, 2, 3. From the inequality sign, I know that this is going to be a dashed line. Arrows on each end. Once again, it's really nice because this is solved for y. It says y is greater than. So this one will also be shade above or shade up, however you like to say it. This is my line 2. So for line 1, we're going to shade above. And for line 2, we are also going to shade above, shade up. Where our crisscross lines, where they overlap, that is our solution. So here I clearly see the lines crisscross, which means it's the shared solution for each. So we take our eraser and we'll erase anywhere that's not where that crisscross effect is happening. So for your 3 solutions, you can choose any 3 ordered pairs in this shaded region counts as a solution. That's it for number 9. For number 10, you're asked to determine if the ordered pair is a solution to the system. For that to be true, we have to be able to plug in this inequality into each, and they both come out true. So let's see if that actually is the case. So this will be 15 times 14, right, because I'm plugging in x is 14, plus 25 times 8, because y is 8, greater than or equal to 300. Let's see. 15 times 14 is 210, plus 25 times 8 is 200, greater than or equal to 300. So we get 410 greater than or equal to 300. That's true. So we're halfway there. If this had come out as false, we would be done. We would say no. But so far, so good. Let's check it in the second inequality. So 20 times 14 plus 30 times 8 less than or equal to 480. See if this comes out true. So 20 times 14 is 280, plus 30 times 8 is 240. The less than or equal to 480 stays. 280 plus 240, we get 520. Is 520 less than or equal to 480? No. False. So because this one comes out false, the answer is no. They both have to come out true for it to be a solution. Looking at number 11. Number 11 is where we start to have some work to do. For my solvers out there, if you would like to solve for y for each of these, you're more than welcome to do so. Just make sure you're very careful with your negatives, with your division and all that. And then you can check your graph against mine, and our graph should come out the same. Those of you approaching this by intercepts, let's do that. So I'm going to talk about this one first, the 2x plus y. I'll label this 1, 1, and this 2. So let's talk about the first one first. So x-intercept, let y equal 0. So we get 2x plus 0 equals negative 2. That's just 2x equals negative 2. Divide by 2, divide by 2, x equals negative 1. Oops. Y-intercept, let x equal 0. So 2 times 0 plus y equals negative 2. And that's really nice because right away that's gone and I straight up get y equals negative 2. Let's graph this first line. So my x-intercept is at negative 1. My y-intercept is at negative 2. From the inequality sign, I know that this will be a dashed line. To know whether or not I need to shade above or below, we are going to check 0, 0. It'll be really quick. So that will be 2 times 0 plus 0 greater than negative 2. We get 0 greater than negative 2. Is 0 bigger than negative 2? It is. That's true. So it means we're going to shade, this is line 1. We're going to shade the side that 0, 0 is on. Here's 0, 0. So for this line, it means we're going to shade above. Or shade up. Because that's the side 0, 0 is on. Let's do the work for number 2, line 2. X-intercept. Let y equal 0. So 2x, oops, excuse me. X plus 2 times 0 equals 2. I'm pulling the second equation. I'll make that one purple to match. I'm doing this one. So x plus 2 times 0 equals 2. Right away, we get x equals 2. For the y-intercept, let x equal 0. So I get 0 plus 2y equals 2. This one is also nice. Divide by 2. Divide by 2. We get y equals 1. So plotting that, x equals 2 for the x-intercept, y equals 1. From my inequality sign, I know that this will also be a dashed line. Let's check 0, 0 really quick. Check 0, 0. So that'll be 0 plus 2 times 0 greater than 2. Ask yourself, 0, this whole left side becomes 0. Is 0 greater than 2? False. So I come back over here and I look at my second line, right? Here's line 2. 0, 0 is on this side of line 2. So if 0, 0 is false, for this line that I'm talking about, the one with the purple dots on it, it means I want to shade the other side. So for this line, it will also mean shading up. So for both of these, we're going to shade up. Let's see what that's going to look like. For line 1, shade up. Keep these roughly as straight as you can, okay? We want to see that crisscross happen. For line 2, shade up. Oops. Where the crisscrosses overlap is my solution. So I'm going to erase. Like here, I just see purple. I erase that. That's not part of the shaded region. Here, I just see blue. So I'm going to erase where I just see blue. So this upper portion is my solution. So for your 3 solutions, again, you could choose any 3 ordered pairs. Any 3 ordered pairs that you want would be an acceptable answer. Number 12, we've got 3 lines as part of the inequality. So that means we're actually going to graph 3 lines. But if you notice, we've got some special cases here. So if you keep kind of confusing what's supposed to be horizontal and what's supposed to be vertical, pay close attention to number 12. So X and a number. Whenever you see X and a number, that's going to be a vertical line, always. So I go to 4, 1, 2, 3, 4. I plot 4 on the x-axis, and based on the inequality sign, I know that this is going to be a dashed line. Now that we've established that whenever we have x and a number, it's always a vertical line, we are now dealing on the x-axis. So when we have x and a number, we are actually talking left and right. So for x is less than, that means shade left. When it's x and a number, that's the only time you will ever have left and right, okay? When it's y and a number, that is always a horizontal line. So for this one, y is less than or equal to 5. We'll go to 5, 1, 2, 3, 4, 5 on the y-axis. Because of the inequality sign, I know that this is a solid line. So we draw that solid line with a straight edge. Your ruler makes a great straight edge. We're dealing with y, so we are back to dealing with either deciding up or down. So for y is less than or equal to, remember, on the y-axis, there is no left or right. Our options are up or down. So for y is less than or equal to, that would mean shade down. And if you write these little directions, these little notes to yourself, it'll help when we go to shade. We still have one more line to graph here, so we're not going to shade yet. For our third line, y is greater than negative 2/3 x plus 3. This is mx plus b. So let's identify m and b. M is negative 2/3, b is 3. We're going to use this piece of information first. So I go 1, 2, 3. As a set of directions, this means count down 2, right 3. So let's do that. From the y-intercept, down 1, 2, right 1, 2, 3. Down 1, 2, right 1, 2, 3. Down 2, right 1, 2, 3. Or from the y-intercept, you could count up to 1, 2, 3. From the inequality sign, I know that this will be a dashed line. Make sure it's nice and straight. Use your straight edge. What's nice is that a third time in a row, this is already solved. This says y is greater than. Greater than means shade up. If you have 3 different color pens or 3 different color highlighters, it makes this a lot easier. If you're just using pencil, that's fine. Just be very clear with the directions of your lines, because now we're going to be looking for where 3 sets of lines crisscross. So for me, I'm going to color code it. If you have highlighters or pens, go ahead and pause it here and go get them. So I'm going to come to my vertical line first. We go back and look at our notes. We said shade left. So no scribbling. Make very clear lines. For the second line, the horizontal line, we said shade down. And for the third line, we said shade up. Let's clean this up a bit. So I'm only looking to keep where I see all 3 directions crisscross. So here, because I used colors, it's even easier to see. I've got 3 colors in play: purple, green, and blue. Here, I just see green and blue, no purple. So this is out. This entire section gets erased. Here is just green, so that's not good. Here is just purple and green, so that's a no. This is just purple, no. And this is just purple and blue. So my solution, oh, and then this is just blue, so this is gone. My solution is that inner triangle, and I'm done. So on tomorrow's test, it's very possible that in the heat of the moment you might get a little lost with your crisscrosses and all of that. If at a minimum you very carefully circle these inequalities that are solved, and if you tell me shade left, shade down, shade up, so I know that you at least understood what you're supposed to do, but then maybe by accident you erased the wrong section or something like that. By having, this would count as work shown. This would show that you understand how to shade. So the more information you put on your paper, the more opportunities you're giving me to see what you know. The more you know, the more I can give you credit for. For 3 solutions, you would be selecting any 3 ordered pairs inside this shaded region of your choice. So I'll leave that for you to decide. Number 13 starts a very important set of real-world scenarios. There will definitely be one of each kind of these on tomorrow's test. So let's read carefully and let's be amazing at these. Number 13, you and your friends have pooled your money and have at least $15 to spend on lunch. I'm just going to make note of that. That sounds like an important total. No charts on tomorrow's test. So you need to know that at least 15 means greater than or equal to 15. How we'll use that, I'm not sure, but I'm going to make a note of it before I keep reading. So you have at least $15 to spend on lunch. You agree to share a large fry and buy hamburgers with the rest of the money. If the price of a large fry is $4.59 and the price of a hamburger is $1.29, how many hamburgers can you buy? Define your variables, write and solve an inequality. So we're going to let X be number of hamburgers. And Y will represent number of fries. Let's write our inequality. So you know a large fry is $4.59, but that goes with my Y values. So I'm going to pull my hamburgers first. $1.29 X plus 459 y greater than or equal to 15. So let's see what we know. It says that you agree to share a large fry. So right away, you know you're only buying a single fry. So I know that this becomes $1.29x plus $4.59 is greater than or equal to 15 because you only bought one of the fries. From here, I can solve for x. Now, in class, when you guys were working on this, some people wrote this right away. They identified the fact that you are already agreeing or that you already know you're buying just one fry. People said, well, you're only buying one, so that's an initial value. That's fine too. Either approach is fine with me. So you decide. If you are more comfortable writing $1.29x plus $4.59y greater than or equal to 15, and say you're only buying one, so that just becomes $4.59, awesome. If you identify $4.59 as an initial value because you're only buying one of them, plus some number of burgers you don't know, that's fine too. Both work. Both are going to get us to the same spot. So to solve for x, we will subtract $4.59 from both sides. Get $1.29x greater than or equal to 15 minus 4.59. If you haven't gotten your calculator yet, go ahead and press pause. Go get your calculators. Do this with me if you didn't do this one. 15 minus 4.59 is 10.41. To finish solving this, we'll divide both sides by 1.29. And we get x is greater than or equal to 8.07. Notice in bold and underlined it said describe your solution in a complete sentence. So I go back and I look, x was hamburgers, so you can buy greater than or equal to. So you can buy at least 8 burgers. Number 14 is a classic car rental question. If my memory serves me correct, there will be a question almost just like this on the test. The key is to realize what kind of question you have here, okay? Let's read it together and decide. It says Budget Car Rental Agency charges $20 a day plus 15 cents per mile, whereas Hertz Car Rental Agency charges $50 a day and 7 cents per mile. How many miles must be driven to make the daily cost of a Hertz rental better deal than a budget car rental? Define your variables, write and solve an inequality. As soon as we see a better deal and we're comparing two companies, we know we're going to start off by getting two y equals mx plus b equations. One for budget, so write budget, and the other for Hertz. So if you haven't gotten out your highlighters, now would be a really good time because we're going to assign budget one color and Hertz another color, and we're going to organize our information. So anything about budget, I'm going to highlight in yellow. It says Budget's car rental agency charges $20 a day, 15 cents per mile. That's what I know about budget. Hertz car rental charges $50 a day, 7 cents per mile. As soon as we have these highlighted, it's so much easier to write our equations. $20 flat for the day, 15 cents per mile. So I know x is going to be number of miles because of the per mile. So y equals $20 per day, flat for the day, plus 15 cents per mile. The other way to know that X is miles, because sometimes people say, well, this is per day and this is per mile. How do I know? Valid question. When in doubt, actually look at the question you're asked. It says, how many miles? So from that alone, I know X is miles. Hertz is $50 per day plus 0.07x, 7 cents per mile. Be very careful not to write that as 0.7 by accident. It'll mess up the whole thing. So we've got our two equations, but we're definitely not done yet because we haven't actually answered this question of which is better. The next most valuable step that I find most of you skip, so please don't, is writing that word inequality. That comes from the question. It says, when is Hertz better? For Hertz to be better means when is Hertz less than budget. For something to be a better deal when it comes to money, it means it costs you less. This is what I mean by a word inequality. And what's awesome about it is it will help you to write the inequality correctly. We want to write Hertz less than budget. So 50 plus 0.07x less than budget, which is 20 plus 0.15x. And from here, it's awesome. We're ready to solve. Remember, when we have variables on both sides, we're working towards a goal of gathering anything with an x to the left and anything with a number to the right. So pause if this is not one you tried already and give it a shot. So if I want to gather just variables on this side, this 50 can't stay. So how do we move a positive 50? The opposite of a positive 50 is a negative. So we'll subtract 50. Notice I'm very careful to write the minus 50 under the 20. Sometimes we get rushing in our work and we write it over here. These are not like terms, so do not write it under something that has x. We have 0.07x less than 20 minus 50 is negative 30 plus 0.15x. Now on this side, we just want numbers. So this negative 30 is fine, but this positive 0.15x, that cannot stay. We'll subtract it from both sides. .07x minus 0.15x gets us a negative 0.08x less than negative 30. Now the fact that I have a negative could be troublesome, but I notice that I have negatives on both sides, so I actually know that I'm okay. Because when I divide by a negative 0.08 on both sides, these negatives will cancel. What's super important to our answer is to realize that we did just divide by a negative, so the inequality sign will change direction. So in your calculator, go ahead and do 30 divided by 0.08. Notice in what I just said, I left out the negatives because I know a negative divided by a negative will be a positive. So you're working on 30 divided by 0.08. When we do that, we get x is greater than 375. We still need to describe our solution in a complete sentence. So to know how to do that comes full circle to, did you define what x is? X is miles. And you were trying to find out when is Hertz better. So let's use all of that to write our sentence. Hertz is better for more than 375 miles. And we're done. (15). This is going to be a fast question. There is one exactly like 15 on tomorrow's test, so please pay attention to 15. Get it right. Sean is getting ready to sell his house. Oh, by the way, it's going to be like 15, not exactly the same question, but like 15. Okay. Sean is getting ready to sell his house. The realtor, came over to do an inspection and share comparable prices of homes sold in the area. The realtor has determined that Sean's house is worth anywhere from $295,000 to $315,000. Write a compound inequality to represent the range of prices Sean can sell his house for. So we're going to let X be price of his house, so price in dollars. It tells me right here, let me make a note about this. This setup never changes. So sometimes I see people doing this. Don't do that, okay? The inequality signs always go this way. The only thing that might change is adding these lines underneath to say the or equal to part. So the price range is between $295,000 and $315,000. All I do is I pull those values and fill them in. So the price range is between $295,000 and $315,000. And I'm done. That's all we had to do. No math whatsoever. Now part B asks, write a compound inequality to represent the range of prices Sean will not sell his house for. Strategy. Even though this did not ask you to graph it, I would literally just do a quick sketch so you visualize what this means. We're saying that he's going to sell his house for anything in this range. So the answer for the, quote, not part will be literally the exact opposite of this. So before you even try to write something, actually sketch what's the opposite. The opposite would be anything on the left or anything on the right. We've got our picture. Now we just need to put it into writing. So literally, how would you say this as an inequality? It's definitely going to be an or because they're going in other directions, right? So X less than 295,000 or X greater than 315,000. Now, this came up in discussion in class today, and it's a valid point. Nobody's going to say you want to pay too much for my house. I'm not going to accept your offer. So in theory, the real world meaning would be they're not going to take anything less than that. But for the sake of taking the exact opposite, let's just leave the whole piece, both pieces together. Okay? But that was a good conversation, so I just wanted to include it here. So again, strategy, draw what it is, sketch out what it is. To get what it's not, literally draw the opposite and then write it. So let's all get this right on tomorrow's test. Please, please, please. Okay, 16. It's the day you have been waiting for, planning your wedding. How exciting. Your parents have given you a budget range of $15,000 to $20,000. You have calculated the cost for the DJ, decorations, photographer, venue, and it will come to $9,000 for those things. The venue will charge you an additional $75 per person for food and drinks. Define your variable, write a compound inequality, and solve to determine how many people you can invite. So right away I know that this will mean X's number of people. Now, as soon as I'm hoping that as you were reading this, you got the sense of a flat rate, right? This is the cost of these things. And a rate per person. So this is going to be an MX plus B between two values. This is one of the kinds of the compound inequalities you have. So see if you can set that up on your own. we're going to have mx plus b between two values. What are you going to write for that? It's going to be the 9,000 flat. That 9,000 counts for the DJ, decorations, photographer, oh, and the venue. I didn't highlight that, but the venue as well. You pay for those things once, plus $75 per person. So there's my MX plus B. And you have this budget range of 15,000 to 20,000. That's what's going to go right here. So this has to fit, this price, MX plus B, has to be between, notice how these go the same way all the time, right? 15,000 and 20,000. We have successfully set up our inequality. Now we just need to solve. There will definitely be a question like this tomorrow, where we have mx plus b between a range of two numbers. The strategy here is to solve from the middle. Keep your eyes on where x is. X is in the middle. That's what we're going to work on. I strongly encourage these two lines because it'll help me to see that whatever I do to the middle, I have to do to each end. Sometimes I see this happen where people will do it to this side, but then they forget to come over here and subtract it from this side. So 15,000 minus 9,000 is 6,000. 75x is still in the middle. 20,000 minus 9,000 is 11,000. This says 75 times x. To undo that, we'll divide by 75. So we get x is greater than or equal to 80, less than or equal to 146.67. Now, this is one you didn't do. Remember, this is intended to be a video answer key. So as soon as I set it up, like if I'm right here and you know how to finish it, make sure that you pause and you finish it, and then we check the answers, okay? Describe your solution in one complete sentence. Well, remember, x represents people. So you can invite between 80 and 146 people and stay within your budget. You could add that if you wanted to. Notice that even though this is 0.67, I did not round up because you don't have money to finish paying for that person. And they definitely won't give it to you for free. So you have to round down. Whitewater rafting. Chase is an experienced guide who takes groups of adults and children out on the water for amazing adventures. The super raft he uses can hold 800 pounds of weight. Any weight greater than 800 pounds will cause the raft to hit more rocks, maneuver more slowly, or potentially sink. All scary things. Chase estimates the weight of each adult as approximately 200 pounds and the weight of each child under age 16 as approximately 100 pounds. So we've got to define our variables first. What are the two people, I guess, being discussed here? Well, we've got adults and we've got students. Adults and children. So let's let x equal the number of adults, and we'll let y equal the number of children. What do we know about adults? Adults each weigh approximately 200 pounds. So 200x plus children, 100 pounds. here's our total. You can hold up to that much weight in the raft. So this will be less than or equal to 800. Now, number 3 says, consider the past 2 trips that Chase guides. Determine whether each combination of people is a solution. Then describe the meaning of the solution in terms of this problem. So X is adults, so this is X, this is Y. Let's plug it in and see if this was an okay trip for him to take. So that will be 200 times 2 plus 100 times 2. And we want to see, is that less than or equal to 800? Well, 200 times 2 is 400, plus 100 times 2 is 200, less than or equal to 800. We get 600 less than or equal to 800. True or false? That is true. So yes, he can take this group and be okay, right? He's under his limit. 5 adults would be a value for X, and then Y is 0, no kids, which makes sense. Let's say there's 5 adults that want to go out. Let's see if they can fit into this raft. That'll be 200 times 5, because there's 5 adults, plus 100 times no children, less than or equal to 800. Let's see. That's gone. 5 times 200 is 1,000. True or false? False. So, no. 5 adults cannot fit in this raft safely. They'll be over that weight limit. To graph, my go-to strategy, guys, and what I recommend to you is by intercepts. So let's just copy this back over. 200x plus 100y less than or equal to 800. Now, if from day 1 you've been following my little titles for the work, we should be able to do this in our sleep. X-intercepts. Let y equal 0. So that will be 200x plus 100 times 0 equals 800. Remember, for intercepts, we're finding an exact point. No more inequality sign for this. We get 200x equals 800. Divide by 200. Divide by 200. X equals 4. I go ahead and I plot 4 as my x-intercept. Y-intercept, let x equals 0. The more you write these little titles, the more it will become second nature. So we have 200 times 0 plus 100y equals 800. That's gone. 100y equals 800. Divide by 100. Divide by 100. Y equals 8. From all of our real world, I know that technically I could draw this line to go all the way through, but in terms of the real world solution piece of this, you can still draw this line all the way through, but all of one side may not be the answer. To figure out which side to shade, we need to check 0, 0. It'll be fast. 200 times 0 plus 100 times 0. Now that we're doing a check, the inequality sign comes back. So let's see. That's gone. That's gone. 0 less than or equal to 800. True or false? I hope we all said true. So let me clarify this because this came up in class. When it comes out true, you shade the side 0, 0 is on. So here's 0, 0. I shade this whole side, but from our real world experience, I know that this is my real world solution because I can't have negative adult rafters and I cannot have negative children. So just this piece right here, and we're done. So any ordered pair in this triangle would work. Remember that if there were any follow-up questions that possibly asked for something on the edge, you would have to check it. We've checked lots of points, so that shouldn't be too bad. Calling cards. You have relatives living in both the United States and Mexico. You are given a prepaid phone card worth $50. Calls within the continental United States cost 16 cents per minute. Calls to Mexico cost 44 cents per minute. So I know the cost of the calls. I don't know how many you have made. So X will be number of U.S. calls. Y will be, or sorry, not calls, minutes. Number of U.S. minutes. And Y will be number of Mexico minutes. And when in doubt, if you look at the B part, that could actually help you. Use the test to help. So if you weren't sure and then you read B part, it says write a linear inequality to represent the number of minutes you can use. It gets me my two kinds of minutes. So don't just say, oh, I don't know how to define the variables and move on. No, keep reading because the test could actually help you out. So let's see. U.S. minutes are 16 cents per minute. So 0.16x plus 0.44y, because it's 44 cents per Mexico minute. Your card is $50. So reason on this. Can you spend more than the card or up till that amount? Right up till that. So less than or equal to 50. As soon as you hit that $50 mark, you're done. To graph, process doesn't change. So on the test, there's like 1 or 2 questions like this. On the review, I think I put in like 6, because by the time you're done with all of them, you should be experts, okay? So I tried to build in as many opportunities to practice these as possible. When you see this on the test, I want you to be like, yay, I know how to do this. So that being said, let's do it. X-intercepts. Leave space to put a label, so move down a little bit. X-intercept, let y equal 0. So that will be 0.16x plus 0.44 times 0 equals 50. And now that I have that written down, I will slide this down. So that's gone. And I get 0.16x equals 50. Divide by 0.16. Divide by 0.16. 50 divided by 0.16, we get a decimal, and that's okay. We get x equals 312.5. So here, let's find both and then we'll graph them. Y-intercepts. Let x equal 0. Use this as a set of directions. So 0.16 times 0 plus 0.44y equals 50. That's gone. Now I've got 0.44y equals 50. Divide by 0.44. Divide by 0.44. 50 divided by 0.44 equals, I got 113.64. So now let's go up here and graph. Decimals are fine. No worries about that at all. Let's get some labels. X is U.S. minutes. And then on the y-axis, we put number of Mexico minutes. If this is 0, this is 50. We're definitely not counting by ones. So if you reason on this, it's divided by 5 lines, so 10, 20, 30, 40, 50. So this is counting by tens. So we're trying to get to 312.5. This is 300. This is 310. So 312 will be right after that. 113, 10, 20, 30, 40, 50. This is also counting by tens. So if this is 100, this is 110. 113 will be a little bit after that. And then we connect it. To know how to shade, let's check 0, 0. Check is very quick, so 0.16 times 0 plus 0.44 times 0. This is where we bring the inequality back, so less than or equal to 50. So this is gone and this is gone. We get 0 less than or equal to 50. Ask yourself, true or false? I hope everybody's saying true. So we shade the side the 0, 0 is on. And notice, for this one, it literally just gave us the first quadrant. So I know it's just going to be this. And it would be nice if we keep this as neat as we can. Doesn't have to be perfect, but neat is nice. We have some follow-up questions here. If you plan on using 121 U.S. minutes, what is the maximum possible number of Mexico minutes? So this is where you could either use the graph, but we're counting by tens. This could be, I don't know, this, like if this is 100, right? Anywhere on here, you could be off by a couple. So my recommendation would be to actually substitute this in. 121 U.S. minutes is a value for X. So I can actually substitute this in. I can say 0.16 times 121 plus 0.44y, and I have up to, so less than or equal to 50, and actually solve. So 0.16 times 121, we get 19.36 plus 0.44y less than or equal to 50. Let's subtract 1936 from both sides. So 50 minus 1936. We get 0.44y less than or equal to 30.64. Divide by 0.44. Divide by 0.44. We get y is less than or equal to 69.63 minutes. So the maximum, you could say up to 69.63 Mexico minutes. And the reason why I left the decimal is you can have a fraction of time. You just won't make it to a full 70. And that one's all done. The same strategy we'll use for E. For part E, if you plan on using 96 Mexico minutes, what is the maximum possible number of US minutes? So the Mexico minutes, recall from how you defined your variables, that's a value for Y. So now it'll be 0.16x plus 0.44, and now we have something to substitute in for 96. For Y. Subbing in 96 for Y, less than or equal to 50, and we're still solving here. So 0.16x and then 0.44 times 96. We get 42.44 less than or equal to 50. From here, it's easy going. Subtract 42.44 from both sides. Keep track of those decimal places, they matter. 0.16x less than or equal to 50 minus 42.44, we get 7.76. Divide by 0.16, divide by 0.16. X less than or equal to 48.5. The meaning, you knew how many Mexico minutes, you didn't know the possible US minutes. The maximum US minutes would be 48.5 minutes. And you're all set. Calcium. Teenagers should consume at least 1,200 milligrams of calcium per day. As soon as you see this, that hints to me of a total. At least 1,200 would be greater than or equal to 1,200. Suppose you get calcium from two different sources, skim milk and cheddar cheese. 1 cup of skim milk supplies 296 milligrams of calcium. 1 slice of cheddar cheese supplies 338 milligrams of calcium. And this comes from Nutrition, Exercise, and Sport. So that's real information right there. Now again, let's say, I'm not really sure how to define these variables. Well, keep reading. Write and graph an inequality that represents the amount of skim milk, and that's being measured in cups. So X will be number of cups of skim milk. And then Y, number of slices of cheddar cheese. So how are we going to put together our inequality? We know information. We know information about how much you get from a cup of skim milk, the calcium, right? 296. So 296x plus how much calcium do you get from cheese? 338 milligrams per slice, so plus 338y at least greater than or equal to 1,200. From here, our process does not change. X-intercept, let y equal 0. Remember, we'll switch to an equal sign here. We're finding an exact point. Divide both sides by 296. We get x equals 4.054, or 4.05. Y-intercept, let x equal 0. So that would be 296 times 0 plus 338y equals 1,200. That's gone. $338y equals 1,200. I'll divide both sides by 338. So we've got 1,200 divided by 338, and that gets us 3.55. So let's get some labels on our graph. X was number of cups of milk. Y was number of slices of cheese. It's nice, our numbers are given to us. X equals 4.05. Here's 4. 4.05 would be right after 4. And then for our y-intercept, 1, 2, 3. 3 is here, 4 is here. 3.55 would be roughly in the middle. Now that we've graphed our points, let's check 0, 0 to know where to shade. So I'm going to slide this up a little bit. Check 0, 0. Now, I have the advantage of being able to switch colors. If you're just working in pencil, it would be nice if you kind of maybe drew a line here to box this off so it doesn't blend in with the rest of your work. 296 times 0 plus 338 times 0. And again, we bring back the inequality when we do a check. We're going to see if this comes out true or false. So that's 0, that's 0. 0 greater than or equal to 1200. True or false? That is definitely false. So, if this is the side 0, 0 is on, we shade the other side. All of this becomes part of the shaded region. Notice I'm very careful to not shade anything that's in the negatives because we cannot have negative cups of milk and we cannot have negative slices of cheese. Determine how many cups of skim milk you should drink if you have eaten 2 slices of cheddar cheese. 2 slices of cheddar cheese is a value for y, because y is cheese. So you're saying let y equal 2, and we can do that. So that will become 296x plus 338 times 2 greater than or equal to 1200. So this becomes 296x plus 338 times 2 is 676. And from here, we're just solving. So if there's something we can add or subtract, we want to take care of that first. I can subtract 676 from both sides. So I have 296x greater than or equal to 1200 minus 676 is 524. Let's divide both sides by 296. We get 1.77. X greater than or equal to 1.77. So we're really not talking partial cups. Greater than or equal to 1.77, our real world answer will be at least 2 cups of skim milk. And we're done. D says, if a teenager doesn't like cheese, what is the minimum number of cups of milk they need to drink each day? So doesn't like cheese would mean they're not going to eat any if they can avoid it. So cheese is, again, a value for y. So we're saying, well, no cheese, that's y equals 0. What's awesome about that is you already did that work, right? If we come back up here and look, you let y equal 0 right here. So you can either realize that you already did this or go ahead and do it again. But we already know x equals 4.5. So the minimum cups of milk, you could say 4.5, but if we're going to round to the whole cup value, at least 5 cups of skim milk. Again, if you did not realize you had already done that up here, no problem. Let y equal 0 right here, and you will again get 4.5 as an answer. Multiple choice. There's going to be a solid amount of multiple choice, so I really want us to go step by step through these and make sure we don't make any silly mistakes. What I mean by a silly mistake is we do our work right, but then we rush and notice, for example, in question 1, A and C are very similar. B and D are very similar. So let's be careful. Line down the inequality sign, divide by -5, divide by -5. That gets me x is greater than -6. That makes the right answer C. Somebody could easily get A if they forgot to flip the inequality sign. Inequality sign flips. When you divide or multiply by a negative. Number 2, line down the inequality sign. Let's subtract 1 from both sides. 6x is greater than or equal to 12. Divide by 6, divide by 6. X is greater than or equal to 2. Right answer is A. If somebody added 1 here by accident, that's where these wrong answers come from. 13 plus 1 would be 14 divided by 6, and you have that right there. If you actually simplified 14/6, you would get B. So notice, wrong answers are not here by accident, so be careful. Just a mistake of adding 1 when you're supposed to subtract could cause you to actually think that this is the right answer, and it's not. Take your time. Number 3, line down the inequality sign. We'll subtract 1 from both sides. 1/3 x greater than 2. To clear 1/3, we'll multiply by the reciprocal, which is 3, and we get x is greater than 6. Right answer is B. Notice how close all of these are. They all have a 6 in them. These are just negative. And then the only difference between A and B is the inequality sign. Careful, 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 careful. Double, triple check all of your answers. There's nothing worse than doing all of the work right and then by accident picking the wrong answer choice. Number 4, has an interesting piece to it. Our answers are in the form of the graph. So let's see what we get. 4x minus 3 will stay over here. Distributing the 2, we get 2x plus 6. To solve this, we'll subtract 2x from both sides to start. Or you could have added the 3. Either way, we'll get the same answer. So I get 2x minus 3 greater than or equal to 6. Add 3, add 3. 2x greater than or equal to 9. I'm going to rewrite that up here. Divide by 2, divide by 2. X is greater than or equal to 4.5. But we're not done yet. We actually have to pick what this means. So 4.5, halfway between 4 and 5. And greater than means to the right. So right away, if I know I'm supposed to be shading to the right, there's 2 here we can actually just cross off right away. These are both going to the left. Greater than means go right. So those 2 are automatically right out of the running. Now notice how close the answer choices are for B and D. This has an open circle, this has a closed circle. Which one is the right answer? There is an or equal to piece to this, so the right answer is D. Take your time. 5, we'll draw lines down both inequality signs. Working from the middle, I'll subtract 4 everywhere. If you do it to the middle, you have to do it to each end. 6 is less than 2x which is less than 8. From the middle, this would read 2x is greater than 6 and less than 8. Divide by 2, divide by 2, divide by 2. X is greater than 3 and less than 4. B. Number 6, we have an and, but notice it's broken up into two inequalities, so we're going to do one at a time. Let's add 9 to both sides. 7m is less than 63. Divide by 7, divide by 7. M is less than 9. For this one on the right side, we'll subtract 1 from both sides. Negative 6m less than negative 30. Watch your algebra there. Divide by negative 6, divide by negative 6. Ooh, divide by negative. Inequality sign flips. M is less than 9 and greater than 5. So some of us are not as familiar with how to graph these, but if I know that 9 and 5 are my key numbers, we'll take a look at what this one is. Negative 8 and negative 4. No. 8. Nope. Negative 5, 8. No. The only answer choice that deals with 9 and 5 is D. And this does represent M is less than 9 and greater than 5. Only in between these two. Remember, ands it will be some combination of dots, open or closed, and in between two values. Always, always, always. Number 7, solve and graph. So let's see. I will add 1 to both sides. 10n is greater than 0. Divide by 10, divide by 10. N is greater than 0. Or, as soon as I see an or, I know I'm going to have a graph going in two directions. I'll have that thought in my head. Minus 1, minus 1. Negative 10n is greater than or equal to 20. We'll divide both sides by negative 10. Dividing by a negative, inequality sign flips. So this is what we're looking for. N greater than 0 or less than or equal to negative 2. Just on values alone, the only one that involves 0 and negative 2, and in fact matches exactly what we wrote right here, is choice B. Eight. The graphing ones, if it solves for y, we're definitely going to use process of elimination. And this is what I mean by that. I have a negative slope. Right away, I know that's a decreasing line. So what can I cross out? If I see an increasing line, that one is gone. C is gone. That's increasing. I know B, my y-intercept, is a positive 1. Do you see any here left that have a negative y-intercept? B has a negative y-intercept. That's out. We're now down to choices A and D. Based on y is greater than, I know that that means shade above. So right away, I know that it can't be D because that's shaded below. So my right answer is A. We did no math for 8. That was purely process of elimination. 9 and 10 are very important questions. There will be one just like 9 and 10 on the test. But I'm not going to tell you which. I'm not going to tell you if they're solved or not. Now, if they're solved, that's really nice. Process of elimination will help us out with something like number 9. For example, the first thing that catches my attention, I should see one y-intercept at 2 and one y-intercept at negative 2. So right away, there's two answer choices that we can actually cross off immediately. Let's go one by one. 2, negative 2. That's fine. 3, 1. No. 3, 1 again. No. 2, negative 2. So now I just narrowed it down to A and D just by looking at the y-intercepts. If I look, solid, solid, dash, dash, there's no difference there. So now I do need to actually reason on the shading. Greater than or equal to means, or just the greater than part, shade up. And y is greater, that also means shade up. So visualize a blank graph. Shade up, shade up. That is my shaded region. So I'm thinking it's A, because notice that's where my shading overlapped. Let's see if we can get D out of the running. Shade up, shade up. So notice, here's the overlap. A is definitely the right answer, because in D, for this solid line, instead of shading up, it got shaded down, which is how it got the crisscross over here. So again, for number 9, we did no math. That was purely a process of elimination question. First, we used the power of our knowledge of where the y-intercepts were to help us out. And then based on the inequality signs, where the shading should be. Now, you very well could have something like number 10, where they're not solved for y. So what are we going to do here? I still recommend my go-to strategy of intercepts. So x-intercept, let y equal 0. This will be for the first one. Y-intercept, let x equal 0. We should have a certain confidence that approaching it this way, we'll get it right every time. So 2x plus 0 equals negative 2. 2x equals negative 2. Divide by 2. Divide by 2. X equals negative 1. And actually, I'm going to pause right there because I saw something even better. But let me finish this, and then we'll talk about it. 2 times 0 plus y equals negative 2. That's gone. Y equals negative 2. So I should have one line going through negative 2, negative 1. So here, check this out. There's no line going through negative 2. Can't be A. That one goes through negative 2. Here, there's no line going through negative 2. Can't be C. Here, there is one. So this one goes through negative 2. Now, let's be even clearer. It's supposed to go through negative 2 and negative 1. That's one of my lines. Let's see. This goes through negative 2. But if you notice, is this line going through negative 1? No. The answer is D. Again, the power of process of elimination at work. That's even stronger element or strategy I noticed, which may or may not happen tomorrow, which is why I wanted to finish showing you this. Notice these inequality signs. They are both strictly greater than, which means that both lines are going to be dashed. D is the only answer choice that has both dashed lines. On that fact alone, you could have chosen answer D. But it would be nice if you could tell me that, okay? If that ends up being your reason, say, I realize both of these are dashed lines. D is the only choice that has dashed lines. Something to help me know you didn't just randomly pick it, okay? Very good. Last two, home stretch here. So the reason I added these at the end is it's good for our brains to go back and forth. So we just worked on some skills questions together. Let's come full circle and round out our review with two more real world. Movies. You receive a gift certificate for $25 to your local movie theater. Matinees are $4.50 each, and evening shows are $7.50. In case you don't know what a matinee is, matinee, like at Buckland Hills in Manchester, right? If you go to a movie before a certain time, more in the afternoon, it's cheaper. That's what's called a matinee. maybe I'm not sure how to define my variables. So for right now, I'll just write x equals y equals. And then when I read B, it says write and graph an inequality that represents the number of matinees and then the number of evening shows. So read for information. It'll help. Let's write our inequality. For space-wise, I'm actually going to probably write my inequality up here so I can use all of this for my graphing work. 450 per matinee plus 750 per evening show. And reason on this, right? You have a gift card. You can spend up to that much money. Once you've used that much money, there's nothing left on your gift card. So up to 25 would mean less than or equal to 25. We have our inequality. Go-to strategy, let's get our intercepts. X-intercept, let y equal 0. So 450x plus 750 times 0 equals 25. That's gone. 450x equals 25. Divide by 450. Divide by 450. Let's see, 25 divided by $4.50. Got 5.555555. So I'll round that to x equals 5.56. Y-intercepts, let x equal 0. That's 4.50 times 0 plus 7.50y equals 25. That's now gone, so I have 7.50y equals 25. Divide both sides by 750. 25 divided by $7.50. We get y equals 3.33. So I'll just say 3.33. It does make sense that we get decimals because if you think about it, if y is 0, that means you're not going to any evening shows, just matinee tickets. Well, very rarely does it work out that exactly $25 is usable, so to speak. Just because you have the $25, it's not going to work out evenly. Same thing here, x equals 0. You don't go to any matinees, you just go to evening shows. You can go to 3, and then you're going to have some change left over on the card, but not enough to use it for another show. Here, you can go to 5 matinees with some change left over. You can't make it to a 6th. For the sake of graphing, let's make sure we have our labels. So number of matinees on the x-axis. Number of, I don't know if I can write sideways, evenings. It's pretty good. Oops, getting carried away there. Even, I-N. I'm just going to go with number of evening. So, here's 5. Let's just check. 1, 2, 3, 4, 5. Okay, so we know it's counting by 1. So this is 5, this is 6. 5.56 will be roughly in the middle. Don't round this to 6, okay? Keep the decimal answers. You don't want to shift the shaded region. You want it to be as exact as possible. 1, 2, 3, 4, 5. I know this is counting by ones. 1, 2, 3, and a little bit. 3.33 will be right there. Let's connect. To know how to shade, let's check 0, 0. So 4.50 times 0 plus 7.50 times 0 less than or equal to 25. That becomes 0 less than or equal to 25, which is true. should we shade the side that 0, 0 is on. Give one possible combination of numbers of matinees and evening shows you can attend. We can pick any ordered pair in here. So like, I want to stay super in the middle just in case. Avoid the edge. So 1, 2, 2 matinees and 1 evening show. 2, 1 would mean 2 matinees and 1 evening show. Any ordered pair in the region. You could have chosen, for example, you know this is 3.33, so you know for a fact that 0, 3 would work. That would mean no matinees and 3 evening shows. Again, you know for a fact down here that this is 5.56, so 5, 0, that would be fair game as well. Lots of options there. Last question, football. In one of its first 5 games of a season, a football team scored a school record of 63 points. In all of the first 5 games, points came from touchdowns worth 7 points and field goals worth 3 points. Last one in the past. We've done a question like this before. To find the variables. Once again, not sure how to do it. Let's keep reading for information. Write and graph an inequality that represents the numbers of touchdowns and field goals. So x equals number of touchdowns. Y will be number of field goals. The team could have scored in any of the first 5 games. So touchdowns are worth 7 points. So 7x plus the field goals, which are 3 points each. This is their record, right? So really think about what that means. If that's the most they've done, then it's possible for this combo to be up to that record. So this differs from the other football question we did, because if I remember correctly, the other one we did said, you know this other team has scored this many, your team wants to win, so it was greater than or equal to their total. Here, we're talking about their own record of 63 points. What's possible that they scored in those games? If that's their record, that's the most points they ever got. So less than or equal to 63. Go-to method is by intercepts, x-intercepts. Let y equal 0. So 7x plus 3 times 0 equals 63. Divide by 7, x equals 9. Y-intercepts. Let x equal 0. Three y equals 63. Divide by 3. Divide by 3. Y equals 63 divided by 3, which is 21. We're ready to graph. It's really nice. Our scale has been made for us, counting by 1, 2, 3, 4, 5. 1, 2. So these are counting by ones, right? 1, 2, 3, 4, 5. X represented number of, let's go check, touchdowns. Y represented number of field goals. Nine would be right here. 21 would be right here. Let's connect it. Let's check 0, 0. So I have 7 times 0 plus 3 times 0 less than or equal to 63. Make sure you bring back the inequality. So that gets me 0 less than or equal to 63. That is true. So we shade the side that 0, 0 is on, which is this one. If you end up going over a little bit, you can just take your eraser and kind of edge it back, okay? C says, give 2 possible numbers of points scored, including the number of touchdowns and field goals for the first 5 games. So you could choose any ordered pair you want anywhere in here. For example, maybe this one. This is clearly on the inside. That's 2 touchdowns, so 2, 10, 11, 12. That's 2 touchdowns and 12 field goals. That would be an insane number of field goals in one game, but hey, mathematically possible. You can say, that's really not as reasonable. I think something more like 5, 6, 7. 7, 2. That would be 7 touchdowns, 2 field goals, and they should hire a new kicker because that would be bad too, right? So you really can pick any 2 ordered pairs you want anywhere in here. You could have picked, this is 9, you could even pick 9, 0. That would mean 9 touchdowns, 0 field goals. Oops, sorry. 0 field goals. So it asked for 2, I just gave you 3, okay? Any ordered pair you want, these points are included. Our intercepts do count, okay? Could have been this one, could have been this one, could have been this one up here, whatever you choose. Just show me you understand what a point in that shaded region means. We are officially done going over our Unit 4 review. Yay! So any questions, please feel free to send me a remind. And your reviews will be checked at the start of class tomorrow. So as soon as you come in for the test, turn in your reviews, and we will sit and ace this test. Have a great night, everybody. Happy studying. Again, please don't hesitate to ask any questions you have on your mind. Bye.